Quasars are cosmic contradictions. They emit dazzling light, yet their brilliance stems from the darkest objects in space, supermassive black holes at the hearts of galaxies. Caught in the black hole's great gravitational grip, gas whirls around and rubs against other gas, attaining tremendous temperatures and thereby lighting up intensely before plunging into the abyss. Recent discoveries of record-breaking quasars have pushed the boundaries of our understanding. In 2021, astronomers reported the most distant quasar ever seen, and in 2024, the most luminous quasar known. The most distant quasar shone less than 1 billion years after the universe's birth, which means that its black hole grew up in a hurry. Did the black hole start small and rapidly swallow lots of new material? Or did the black hole begin life big and grow even bigger? Meanwhile, the most luminous quasar demonstrates just how quickly a black hole can swallow gas and grow larger. Because supermassive black holes reside at the centers of most large galaxies, including our own. Similar processes likely once affected the central regions of large galaxies throughout the cosmos. California Institute of Technology astronomer Martin Schmidt found the first quasar in 1963, when he realized that a blue star seemingly in our galaxy was actually far beyond it. The clue came from the blue object's redshift. As light waves from a distant object speed through the fabric of space, space expands and gradually stretches them to longer or redder wavelengths. The farther the object, the more space the light has traveled through, and so the more stretched out the light waves become. Schmidt recognized that the object, named 3C273, had spectral lines with wavelengths that were 16% longer than normal. In astronomical parlance, its redshift was 0.16. This redshift, coupled with the universe's expansion rate, implies a distance of some 2 billion light-years. To be so easily visible across such a vast distance, the object must far outshine the entire Milky Way galaxy. The next year, American astrophysicist Hong-Yi Chu called these objects quasars, a term that initially made a bigger hit with the public than with his peers. Only in 1970, well after the introduction of quasar televisions, did a leading astronomical publication allow the word. The Astrophysical Journal has up till now not recognized the term quasar, and it regrets that it must now concede, the editor lamented. Quasar stands in part for quasi-stellar object. Like stars, quasars appear to us as mere points of light. This is because the hot, luminous gas swirling around the supermassive black hole occupies a region smaller than our solar system, minuscule in cosmic terms, that lies extremely far from Earth and outshines the host galaxy. Quasars were most common long ago, between redshifts 2 and 3, when the universe was 2.1 billion to 3.3 billion years old. At that time, the universe was smaller and more crowded, so galaxies collided more often, spilling gas into the supermassive black holes at galactic centers, and the universe had not converted as much of its gas into stars, and thus was more gas-rich. At still greater distances, which correspond to even earlier epochs, quasars are rarer. Far-off quasars are also harder to detect. It's a very challenging task to find such distant quasars, says Feige Wang at the University of Arizona in Tucson. Not only do they look fainter, but expanding space also stretches their light enormously. As a result, though most quasars are intrinsically blue, remote quasars look red, lost amid the Milky Way's many dim red stars, as well as compact ruddy galaxies beyond. In November 2019, two of Wang's Arizona colleagues, Xiaohui Fan and Jinyi Yang, were at the Magellan Telescope in Chile hoping to find a distant quasar. The weather was not very good, Fan recalls. One by one, the spectra that the telescope was recording showed that the dim red specks on his list were foreground stars or galaxies, not far-off quasars. But Wang had highlighted one faint object in the constellation Eridanus that had unusual clouds arrived just as the object was rising. So we caught the last chance to observe it, says Fan, who, within seconds, saw a quasar farther than any other known. Its spectral lines were shifted redward by 764%, giving it a redshift of 7.64. Then the clouds came in, he says, and then we closed the telescope. The quasar, named J0313-1806, is 13.1 billion light-years away. The high speed of its orbiting gas indicates a black hole with about 1.6 billion times the mass of the Sun, 400 times that of the supermassive black hole at the center of the Milky Way. Yet the quasar shone when the universe was only 680 million years old. How did it grow so big so fast?